Let's talk about this first order linear equation. The idea is that if the left hand side would look like this, then we would write it in this way. It would be a derivative of a product. We would be able to integrate on both sides, and in the end we could solve for y. The next realization is that we can always arrange the left hand side to look like this. The derivative of the integral of p would be pp. The derivative of the exponential of the integral function of p would be this function here. It happens to be so that this function is very useful now. It is called the integrating factor. If we multiply our equation by the integrating factor, we get the equation in this form, and now it happens to be that we get here some function a and its derivative here. Now it is useful to write the integration constant here. And here's a mistake. Of course we need to multiply with the same function on the right hand side also. So we need to add that. Here is our solution. So to solve this first order linear equation, we have two methods. If we remember the solution formula, we can directly use that. Or if the formula is too complicated, then perhaps we just remember that we were using this integrating factor, and in that way we got the solution formula. Let's try to solve this equation. We can find the function p and calculate its integral function. Then we find the exponential of the integral function of p. Let's now assume that x is larger than 0, so that we can just forget these absolute values from here. And then we get some integral what we can integrate. This integral we can calculate by using integration by parts. Now we are ready to write our solution. In the front we will have the inverse of this function. Then we will have the brackets, and we will put here the first function and the integration constant. And there is our solution. Let's also check our answer. The derivative of y would be, we can calculate by using the differentiation of a product. And let's first differentiate this function and then this function. So we would get at first something like this. And then the other part would be need to differentiate the function in the inside, and what we will get the derivative of minus cosine is just sine, so we will get x times sine of x, and then the derivative of sine is cosine, and the derivative of the constant is 0. And now here these cosines will cancel out, and then these x's will cancel out. Now we see that if we would calculate the left hand side, we would have there this derivative of y, and then plus 1 over x times y. Well, if we make calculate what is 1 or x times y, it's something that will cancel out with this factor here. So in the left hand side we'll just get a sine of x and the equation is satisfied. Let's try to solve this equation by not using the formula. So we will try to make out the integrating factor. We should see that these are function p. This is the integral function of p, and the exponential of the integral function of p would be, let's see, it would be something like this. In this case, we don't need to have this integration constant here. So we are led to the conclusion that we must multiply both sides by this function. We have multiplied by this function. We see that the left hand side is a derivative of some function. There is a mistake, there should not be any prime there. Here we have done the integration and we will get our solution. Now in the right hand side we got some integral which we cannot calculate in a closed form. But of course we can calculate some values for this integral by using the computer. Also we can make the thing a little bit more exact by putting the limits to the integral and changing the variable in the inside. Fixing the lower limit of the integral will just fix the constant. Now we know how to solve the first order linear equation. In the solution formula we have many integrals. We have the integral of p and then also this other integral, and sometimes we can calculate these integrals and sometimes not. If we can calculate the integral, our solution can be written in a nice way. And if we cannot calculate the integral, then maybe the solution will look a little bit more complicated.